Morning, ninth grade. We are ready to do 8.11 and 8.12. Nobody called me yesterday on the quiz, so I assume that you got all the answers correct, or at least got an answer there. Whether they're correct or not, I'll check that. Be sure to bring them back this weekend when you come back to pick up your next set of tests and quizzes, whatever. Yeah, 8.11 is very similar to what we did the other day. It's just we are again working with only the denominator, the bottom one, and we're just equating it out to see what it values. So I copied the first one on the board, 3x and 2x. You take the 2x and bring him over here and equal 0 to see the value of x. And so if you work him down, 2 divided into 2, and then 2 divided into 0. Now be careful with this. Sometimes you get caught and you think, oh, that's 2. No, it's not. 2 into 0 is 0. So for your first answer, x equals 0, or the value of x is 0. Now you can check it. I didn't check any. If you look at your examples in the book, it will show you how to check it. You can put 0 in there, 2 times 0. Yeah, you got it. I skipped over a bunch of them. I come down to number 5. Here is a trinomial, and we're breaking it down to a bi. And again, I just use the denominator, x squared negative x negative 6, and then I just quickly put the 0 on the back to start the equation. You have x squared, so I put an x here and an x here. And I back up here on that same old road I told you the other day. You have a negative answer here. The last term is negative, so that means you'll have one positive and one negative in your answer. So I put a negative here, and I put a positive here. Now you need to get your exponents that will equal negative 1. Your exponents for 6 are 2 and 3. And if you got 2 and 3, and you add 2 and 3 together, and you come up with a negative answer, negative 1, that means your 3 has to be the negative one, and your 2 has to be the positive one. So now you find the value of x negative 3, and I did that right here in a quick form. That's 0, x 0 plus 3 equals 3 positive. And over here I did the 2, I broke the 2 down, so you got 2 plus x plus 2 equals 0, so I subtracted the 2, subtract 2 from 0, you got a negative 2. X equals negative 2. So your answers for number 5 on part A is 3 and negative 2. This is almost identical to what you did the other day, except it's just in the fraction form. I also did 7. He's a little bit different. You have your x squared, and then you have parentheses 2x plus 1. So let's break the x squared down first. And you square the x, the value of x. So if you look, it wasn't too hard. X equals 0, and that's your answer. So your first one for number 7 is 0. And then take your x, 2x negative 1, and equal that 0. And so here I isolated the 1, I took the 1 negative and I made it positive, and then I switched it around, this side. And then I made the 2x equals 1, and I divided the 2 into here. I divided the 2, and whoa, I come up with a fraction, which, that's no problem, x equals 1/2. So for your number 7 answer, x equals 1/2 and 0 are your 2 answers for that one. Yeah, I'll let you go ahead and finish that for 8.11. I'm going to roll over and we'll do 8.12 here. Do a couple problems of those. I'll center this thing here so you can see the numbers between the highlights, the light bulbs. How's that sound? think you can see that. 8.12 and number 1. I'll read the problem, and it goes something like this. During a basketball game at lunch break one day, James' team scored 39 points from 22 baskets, consisting of 1-point free throws and 2-point field goals. How many of each did they make? This sounds to me like our recess time with 7th and 8th and 9th grade boys playing. So it's a two-step equation, and I am not sure why they put it in this way, because I don't see an example like this. So number 1 and 2, I will work out here on the board. They are a little different than your examples. 3 and 4 are like your examples in the book. You have F. I put F for free throws and G for field goals. So your first equation, you have so many free throws and so many field goals, and you come up with 22. Uh-oh, somebody's trying to call me. I'll tell them to wait till later. How's that sound? And for B, you have the second one, you have 1 point for your free throws, and then there was 2 points for your field goals. And the points totaled at 39. So you'll have to do a subtraction of these two equations. Here he's trying to call back again. Now, take this here, and there's 2 ways of doing this. The way they did is subtracted the 1-point free throws from the equation. So if I can end this, if you go 1 negative times F times plus 2F and 39. So I put 1 negative here, makes you 1 times 39 is negative 39. And actually I moved this and over here, okay? I've got negative 39 here, then I've got negative F and negative 2G. So here is this same problem. I subtracted the 1 point from there. So 1F plus 2G equals 39. And I took these two problems and I combined them. I put them together now. And that left me with G. This person is serious trying to get a hold of me. Let me see if I can just end this. There we go. This is G. If you subtract 2G from 1G, you come up with negative G. If you subtract negative 39 from 22, you have 17. So your answer is G equals 17. Now they're both negative, so I went and made them positive. I don't know if I would have needed to or not. Yes, I needed to, but this is the way I changed the two negatives. So I had G equals 17. There is a shortcut here, and I'm not sure if I should tell you or not. You could have shortcutted this here by simply subtracting this one from A equation from B equation. There's two equations, the way they're set up, and you could have subtracted A equation. So if you subtracted F from F, you'd had 0. Subtracted G from 2G, you'd have had 1G. And then subtracted 22 from 39, you'd have had 17. So you had G equals 17. I'm telling you this, that's not exactly the way they want you to work it out. Now you had 17 field goals. This is G for our field goals. 17 field goals, you had a total of 22 points. The way to find out how many free throws there were, you have to subtract. Or you had 22 total. Subtract the 17 from 22, leaves you with 5. So your two answers, there was 17 field goals and 5 free throws. Number 2 is identical. And I just about told you, you figure number 2 just like I figured this one, and you'll get it right. Well, I'll assist you. There were adults. I'm not going to read it. There was children and adults, and they sold, well, maybe I should. At the Acton County Center held a pancake breakfast to earn money for their children's playground, selling 374 tickets for a total of $2,009. If adult tickets were $7 and children's tickets were $4, how many of each did they sell? Okay, so adults is A, children is C. So you got A, adult tickets plus children's tickets equal 374. That's your first equation. Go to the second equation and then equate into that the value of the ticket. So the adults were $7 and the children were $4. Can you, comes off the board. No, let me turn that over. There we go. $7 and $4, and then the total was $209. Now you'll need to subtract the $7 adult price. So if you take this here equation B and bring it down here and subtract the $7 from here, you will figure up for the children's. Okay? So now, don't look down here at the answer. I'll hold my hand over that. You subtract the 7, you put -7 on this equation, because you're going to subtract the $7 adult. So you got -7 times A makes you 7A, -7 times C makes you -7C, and then you go -7 times 374, you're taking off the $7 plates, makes you a -2818. So this is your answer. So this in here, subtracting the 7. Okay, now you take your equation, your regular equation of the 209, which is this one here. You bring it down here, and you got 7A, so you will combine the two equations, or you can say I can subtract them. However, 7A from +7 from -7 erases this one. 4C, the 4 from the 7C makes you 3C. It is a -3C because this was negative. And here you have a -2618. You take the $209 away from it, you come up with $603, and it's negative again. So you have 3C, take your 3, divide it into here, a -3 into -3 eliminates it, -3 into 603 brings you down to 203. Whoa, that can't be right, 201. I must have miscopied that. Or I figured it in my head and I figured it wrong. That's what happened. I've had 3 into 6 is 2, 3 into 0, and 3 into 3, I said it's 3. I was wrong, 201. Now, I got this answer wrong here now. I had 201 here, so I subtract 201 from your total plates of 374 plates. So I take 1 from here, this makes this a 3. I should have checked the answer key before I started this video. 1 from 4 is 3, 0 from 7, 2, yes, 173. So there's 173 adult plates, 201 children's plates. Let me see if I got that correct. $201 children's plates. No? That's correct. No, 171. I'm still wrong somewhere. My book is telling me it's 203. And oh, I see where I made right here should have been 609, and that would make this a 3 again. I was right to start with here somehow. I just made a mistake, and 73 make me 71. That is a correct answer for you. Now, if you would give me just a second, and I will go to number 3, and I didn't have room on the board, so I'll erase one of these here. Let me see if I erase where I can erase over here and do number 3 for you. Number 3, you do not have to combine two equations like you had to in these problems here. 3 says, Garrett had twice as many quarters as $1 bills, all totaling $25.50. How many of each did he have? Okay, you have quarters and $1 bills. So it's $25.50 is his total. He has $1, and I'm going to abbreviate this quickly. He has 25 quarters, and he has 2 times. So let's go D for dollars, 100D, and then let's go 25. Let's go 2D. It's 2 times. I don't know, maybe I should put the 2, I should put the D back here for just name both of them D. Or maybe I should, yeah, I will just leave them both D. Now, he has 2 times as many quarters as he has $1 bills. So just forget the decimal, because we skipped it out of here, we'll skip it out of here, and we'll skip it here. So 2 times 25 makes you 50D plus 100D. I won't copy that down. I'll let you do this. So this here makes you 150D. And of course you go 150 to isolate the D. We better catch up this other side here. This looks kind of poor. This is 2550. And this is 2550 again, divided by 150. Whoa, I stopped. It's your problem to figure out how many dollar bills he had. You use your calculator or your head. Yes, your head. And then when you find out how many dollar bills, that means he'll have twice as many quarters. Thank you, and enjoy your lesson.